All right, so in this problem, we're asked to kind of verify one of the properties of determinants. And the property that is being illustrated here is that if you take a matrix, ignore these k's for a moment. If you just take the A matrix and you multiply one of the columns by k, which is what we've done here, we've just multiplied one of the columns by some constant and found the determinant of this. Okay, so that's what we've got to show. In fact, I should write it this way. If I find the determinant of that matrix of the A matrix where I've multiplied a column by k, put this in there. So the determinant of that matrix, it should equal what I would find if I just find the determinant of just the plain A matrix and multiply that determinant by k. Okay, so again, multiply by k and find the determinant. That's what's happening here. Should equal find the determinant and multiply by k for the A matrix, right? If you multiply a column or a row. So the process to do this is actually to go through and find the determinant. Now, since this is a 3-3 matrix, we can we can find the determinant using our little shortcut, which is, if you remember, we write down the matrix. And then we copy down the first two columns again. Right, this was our shortcut for a 3 by 3 matrix. Sorry, I got the A22. That's got to be A sub 2, 1. A sub 1, 2, A sub 2, 2, A sub 3, 2, right? And so the process for finding this determinant is to multiply down that diagonal. And when I do that, I'm going to get k times A sub 1, 1, A sub 2, 2, and A sub 3, 3. And then multiply down this diagonal. And that's going to give me A sub 1, 2, A sub 2, 3, times k A sub 3, 1. And I'm going to add those results. And then multiply down this diagonal, which gives me A sub 1, 3, k times A sub 2, 1, times A sub 3, 2. Okay, now notice that there is a k in each of those terms. So I could factor that k out. So I just want you to imagine, I don't want to write them out, but I want you to imagine you pull that k out and you're left with this plus this plus this, right? But now we're not quite done, of course. We have to go the other direction, which is to go this direction, multiply down that direction, A sub 1, 2, k, A sub 2, 1, A sub 3, 3, plus, hit this next diagonal right here, k, A sub 1, 1, A sub 2, 3, A sub 3, 2, plus, down this diagonal right there, A sub 1, 3, A sub 2, 2, k, A sub 3, 1. And we have, once again, a k in all of those. So I can factor out a k from all of those. Oh, by the way, I'm not quite done. I need those added together, those added together, those added together, and then subtract. And that's the derivative, or the determinant of this matrix, right? But I could clean it up by factoring a k out of the whole thing. Now notice, if you factor a k out of the whole thing, what are you left with? You're left with A sub 1, 1 times A sub 2, 2 times A sub 3, 3, right? Plus A sub 1, 2 times A sub 2, 3 times A sub 3, 1. Which, if you go through this process, for this matrix, it's going to end up with looking just like this without the k's. And so if we multiply by k, that gets us this, right? So we just did one side of this, but if you were to find the determinant of this matrix, you would multiply down that, and boom, there's your A11, A22, A3. You'd multiply down that, there's your A11, or A12, A23, and A31. And then you'd multiply down that, and there's that. Right? So, well, all we're doing is we're verifying that these two things are truly equal by finding their determinants. The big pain is you have to work with all these subscripts and keep everything in place. But the big breakthrough is that when you do the determinant of the left-hand side, everything has a k in it, so you can just factor it out. Bam. And that should show you how to work with this problem and other ones like it. No.